Welcome, everyone. Good evening, and welcome to tonight's program sponsored by the Metro West Climate Solutions. I am the Reverend Dr. Stephanie May, a member of the steering committee and minister at First Parish in Wayland. Metro West Climate Solutions, or MCS, is a partnership of congregations and organizations in the Metro West area, including First Parish Church in Weston, First Parish in Wayland, First Parish in Lincoln, Sustainable Weston Action Group, and a growing list of organizations and individuals. Our mission is to foster sustainable, resilient, and low-carbon communities and host timely and relevant programs that encourage people and organizations to get involved in bringing about solutions to some of the great challenges of our time. While the challenges are immense and global, the solutions are mainly local and certainly involve all of us who reside here in industrialized countries making different choices regarding our food, transportation, and energy use. All of us have a role to play in moving our society and economy towards a low or no carbon future. For more information about our work or to view recordings of some of our past programs, go to www.metrowestclimatesolutions.org. And now, as we begin, we'd love to know where you are joining us from. If you could please take a moment to just answer this poll. So I'm going to go ahead and end the poll. You should be able to see the results. Looks like Lincoln is our winner for attendees tonight. And now please welcome the Reverend Jeff Barsnell as he introduces tonight's program and speakers.
Thank you, Stephanie. And I see that folks from Newton chimed in that they're here too. So welcome to all of you. Tonight's program was inspired by a series of local conversations and projects. This time having to do with a spike in interest in installing on-site battery backup power for one's home or business. This is a conversation that I'm hearing increasingly amongst people here interested in climate issues. With the introduction of residential scale or whole house batteries, a growing number of property owners are looking to install batteries on site that work with solar panels on their roof. Now, it's one thing to generate electricity on site using solar panels on a roof that then feeds into the local power grid. It's quite another thing to install a large battery system that stores solar energy on site and can support the local grid when there is a surge in demand locally, or provide 10 to 20 hours, sometimes more, of backup electricity during a power outage. This changes how property owners interact with the local electric utility and how the utility manages the power in the local grid. There are a variety of different issues and challenges involved here. On one hand, there are understandable building and fire safety considerations here, with installing a large battery in a side room or in a basement of a home or office building. What permits? What permits need to be issued by local building and fire authorities? What regulations and building codes need to be adhered to and followed? If the larger goal of our region and society is to reduce our dependence on fossil fuels, then how we electrify our homes and cars must involve questions, inevitably, of safety, of feasibility, and equipment management. On the other hand, as we think about issues of on-site energy storage, we need to step back and ask some questions about the supply chain that provides lithium-ion batteries, all of the lithium-ion batteries that power our 21st century electronic lives. It turns out that many of the sources of lithium in our phones, in our laptops, and in our whole house batteries come from countries like the Democratic Republic of Congo, where there are a whole host of concerning and alarming human rights abuses and environmental degradations associated with cobalt and lithium mining. Just earlier today, the well-known journal Foreign Affairs published a review of the new book by the human rights and anti-slavery researcher Siddharth Kara that documents the very concerning human rights abuses in the largest cobalt mines in the world. And a link to Siddharth Kara's book, Cobalt Red, I believe is posted in the description on the website. The book by Kara describes a system of intermediary agents that connect the abuses of minors in the Congo to major electronics manufacturers, companies that all of us know and love. For tonight, we have two presenters. Matt Honkonen is a senior systems designer and sales manager at East Coast Solar out of Worcester, Massachusetts. Matt is a local solar professional with over 7 years of direct industry experience. From an early age, he felt the pull towards environmental protection and sustainability, partly instilled by his father, who worked for the state of the Commonwealth for many years, and now is with the U.S. Forest Service. From completing his education in the White Mountains to exploring the Rockies and beyond, Matt has clients between Massachusetts and California, and has been an integral part of the success of 2 local solar companies during his tenure. In addition, Matt founded Regenterra, a company focused on bringing sustainable fertilizers and garden amendments to the marketplace. Matt's firm, East Coast Solar, is a turnkey solar construction firm specializing in residential and small commercial solar and battery storage projects. Their staff all have a significant background in solar and construction management, and each project receives individualized, dedicated attention from first conversation through project completion and beyond. They are currently working as one of the preferred solar consultants for Energize Wayland. Jim Metcalf is a local resident of Wayland. He has worked as a meteorologist and researcher at the Air Force Research Lab at Hanscom Air Force Base for many years. He and his wife Jill installed a solar photovoltaic system on their home several years ago, and then decided to install 2 Tesla Powerwall battery units as a follow-up project. They are one of the first homeowners in Wayland or in the area to do this, and we will look forward to hearing about their project and experience. We will hear first from Matt and then from Jim. After their slideshow presentations, we will then have some time for Q&A and discussion. As always, we invite you to submit your questions using the Q&A button on the bottom of your Zoom screen if possible. I know, believe me, I know, it is tempting to use the comments button and share your question via comment, but it is easier for us to organize and see your questions if you use the Q&A feature in Zoom. And now we welcome Matt Honkonen.
Jeff, thank you so much to you and to all the folks at Metro West Climate Solutions. We appreciate your support in helping residents understand the solar and battery storage marketplace, along with other sustainability initiatives. And I'm excited to present to you folks tonight to get a better understanding of what the battery storage marketplace currently looks like. We're going to get into a good level of detail. Of course, there's always areas that we can elaborate, and this will be available as a recording on the Metro West Climate Solutions website following tonight's webinar. In just a moment here, I'm going to share my screen, and we're going to go through a brief presentation that outlines the majority of information I think most homeowners would like to see as they understand their potential for solar and battery storage. So give me just a moment here. I'm going to start my slideshow, and then we will share the screen and be off. All right. So once again, I want to thank Metro West. Again, my name is Matthew Honkonen, and I am the Senior System Designer and Sales Manager with East Coast Solar. As Jeff mentioned, we're a turnkey solar contracting firm that's based in Worcester, Massachusetts. We do cover the large majority of Massachusetts. And sorry, just a technical difficulty here. Need to change screens. There we go, folks. Apologize. I did just want to briefly outline today's organizations. Metro West, as you know, and I appreciate folks who are just joining us for the first time. East Coast Solar, again, company I work for as their full-time representative. I also wanted to mention here Energize Wayland. I got familiarized by Metro West Climate Solutions by my relationship with Energize Wayland. They're another local organization that helps folks understand the pros and cons of solar battery storage. They do have some local independent solar coaches that can help folks further understand what the marketplace looks like, along with myself as an industry professional. We've got some great resources there. And again, this isn't specific to Wayland. I know that we do reach a number of different communities. Websites all listed below here for you. So a brief overview of what we'll be talking about today. I'd like to give you a general introduction of solar and battery storage to just understand the basics. We're going to get into the battery chemistry and how different chemistries have different pros and cons and different means of use for the variety of projects at home. We'll go through a typical installation and what does that look like from start to finish. We also have a case study here this evening that's going to speak after this presentation to get into a little bit more detail of what a real life experience looks like from one of our local residents. We'll go over some popular options. There's a number of manufacturers on the marketplace that offer reliable solutions, but this list is growing and certainly dynamic as the landscape is changing. We do want to touch on potential greenwashing, how to avoid that, humanitarian issues. As Jeff mentioned, cobalt is a major element that's present in most of the battery storage that's on the marketplace today. And that does come with some very unfortunate consequences for folks of the native areas where this mining is happening. I'd like to go over some technical considerations and the regulatory framework that's to be expected as you move through the process of understanding batteries and what they can do for your home. We'll also touch on incentives. So we have some local and state incentives associated with batteries that help you reduce the capital costs of installing these batteries. And then I'll touch on some further considerations that are a bit more specific based on the needs of the home. So here's a brief introduction to battery storage. Roughly in about 2010 is when we saw residential batteries start to enter the marketplace. About 2015 is when we really started to see them pick up steam. That's when you saw the first iteration of the Tesla Powerwall. There's a company called Sonnen, who's a German manufacturer, who was one of the first batteries to enter the marketplace. And so these companies, of course, are looking to support sustainable development and typically to be paired with a solar system. You don't need a battery in many cases. In situations like we have in Massachusetts, we don't get charged time of use. We don't get charged different rates throughout the day for the most part. So unless your major concern is having power in the case of an outage, then you don't necessarily need a battery. And it certainly does add a significant cost to every project. And we'll get into that into a little bit more detail as well. But that's something that, of course, we just want to make clear for folks that you don't need a battery unless you really feel like it's something that you want for peace of mind at home to make sure that you have some type of energy connection if the grid goes down. The way I like to compare it is to a generator, right? Traditional gas generator does have some drawbacks in terms of its emissions, its fuel costs, annual maintenance, and then, of course, the upfront capital costs of a generator. And a battery acts in a similar way in terms of its power supply, but it has a few clear advantages. It doesn't have the emissions. There's no fuel. There's very, very little noise associated with these batteries. And it's, of course, much more sustainable since you're charging the battery through your own solar systems production and then discharging that battery to feed your home if and when the grid goes down. Some challenges that, of course, we want to mention, there is an added upfront cost. So that, of course, is to be considered, as solar already is a significant investment for many folks. There are different options on the marketplace in terms of owning the system, leasing the equipment. We typically only recommend owning the equipment, and whether that's paying for it through cash savings or utilizing a solar loan or similar type of financing to pay for the project, we always recommend that all of our customers own their system, which and then would lead to all of the benefits that we'll discuss here. All the incentives then go directly to the homeowner. Another challenge, though, is that batteries do have a limited power supply. And there's several different iterations of this that we'll discuss. There's a certain capacity, which we refer to as a kilowatt hour. Most batteries to feed homes are going to fall somewhere between 10 to 30 kilowatt hours based on the needs of the home. And of course, that is also variable based on the use case that we go through with folks. Safety issues, I do want to touch on this, although I always tell folks it really isn't a major concern. This is going to be commonplace when we refer to batteries with solar systems in the coming years. I can see that evolution throughout my tenure so far. And as we look to evaluate the future economics of these projects, I can reliably say, based on my professional opinion and everything that I see, that I am quite sure most solar systems, at least residential solar systems, will be paired with the battery within the next 5 to 10 years. The safety concern, again, potential fire hazards, it's very low. We're going to get into the fire memorandum that's been released by the state fire marshal. But again, as long as batteries are installed by a certified professional who have the training to understand these components, there's very, very little risk that it would cause any issue for your home. Another challenge that we'll discuss is the current regulatory framework. So we do have fantastic support from legislators that put sustainability initiatives in place for Massachusetts when it comes to policies like net metering, which is the agreement between homeowners and utility companies that give you nearly retail value for the export of your energy, which is now becoming rare throughout the country and throughout the world. Massachusetts does have some of the strongest regulations when it comes to solar and battery storage. However, it's oftentimes gets diluted as we go from the top-down approach with press releases and memorandums coming from the state, and then translated by local officials, whether that's building or electrical inspectors, local contractors, and then of course, homeowners and business owners as they look to evaluate these options. So there is some confusion there. And it's something that I think we need to find a place for in our solar marketplace. And we'll touch on that a bit more as well here as we move through. So I'd like to compare two types of battery chemistry for you today, which are the two most popular types of chemistry right now that are on the marketplace. We've got lithium ion, or NMC, which stands for nickel, manganese, cobalt, or we have lithium iron phosphate. So we'll start with the NMC batteries, which are referred to as the traditional lithium ion. These batteries typically have the highest energy density, meaning that they can supply the greatest amount of energy upfront for significant power loads in your home. They do come with a lower cost traditionally, based on the economics, both domestically and internationally. One downside is that they do have a little bit of a faster degradation, meaning that they will hold less of their charge throughout their life cycle. Thermal runaway is one of the main risks for a lithium ion battery. Now, this is the risk that's being addressed by the state fire marshal and other officials to cover a variety of different batteries. But again, I feel that there is a potential gap in the marketplace and with this regulatory framework to understanding what's the risk associated with different types of batteries. Cobalt, again, the main concern in an NMC battery. We'd like to see the industry move away from traditional lithium ion and cobalt-based batteries because of these issues. I don't feel that we're going to see any quote unquote clean cobalt, although I'm sure that there are processes in place now that this is being brought to light by Siddharth Kara and other journalists that are bringing these issues, to us. It's very terrible what's happening here. And I do encourage folks, following this to do a bit more research on cobalt red, again, which is Kara's book that just came out recently, to understand the scope and the magnitude and the depravity of what's going on with cobalt mining. And regardless of what any big company tries to tell you about their supply chain, I'd be very hesitant to think that there's no risk associated with these humanitarian and environmental issues associated with cobalt mining that ultimately end up in our products. And I think it's important to understand where your purchase decisions are going and to have that transparency behind these products, which of course we're using in the name of sustainability. And again, we would like to, avoid greenwashing if we can. Now, with the NMC batteries, there's very little opportunity for domestic mining. It does happen mostly on the international marketplace. As Jeff mentioned, mostly in the DRC in Africa. Most of those mines are owned by Chinese corporations, and we'll touch on that a bit more here in just a moment. The alternative technology, which is slowly gaining popularity, and what I feel is going to be the technology commonplace here in the future, is lithium iron phosphate. It's been seen and proven to be a safer chemistry overall. It doesn't have as great of an energy density, meaning that it doesn't have quite as much capacity or initial power output, but it still satisfies most of what we need for our loads at home. There is a higher cost associated with lithium iron phosphate batteries, and that's due to the integrity of their materials and the manufacturing processes and some of the value features that come along with them, which, as we look to the next point here, is a lower degradation. So over time, lithium iron phosphate batteries will hold their charge at a greater capacity. Now, we will touch on warranties as we look at different battery options in the marketplace, but this is an important consideration. And I do feel that a number of companies will put what the consumer wants to hear in a warranty, and the private industry, of course, has proven a little bit differently when it comes to these chemistries. And I'll talk to you a bit more about what we're referring to there as we look at specific manufacturers. There's also no thermal runaway with a lithium iron phosphate battery. And I should have perhaps prefaced this, but thermal runaway can happen if the battery reaches too high of a temperature in its operating environment, if it gets pushed or dented or somehow damaged. This can also happen with thermal runaway. Again, it is very rare, so I certainly don't want to fearmonger, in regards to this part of our conversation. It is very, very rare, but it is a higher risk associated with NMC. And I don't want to say no risk in this life. I'd really hesitate to say, anything is impossible, but you don't see it with lithium iron phosphate batteries. And I would say here too that, I'm not a chemical engineer, nor am I a classically trained electrician, although, I certainly have affluence as far as layman's terms are concerned, for both of those areas. But this is why we have teams in place that can speak to the exact needs of a project and the exact electrical specifications that are needed or required by these technologies. I think it goes without saying there's no cobalt in a lithium iron phosphate battery, so we avoid those humanitarian and environmental issues with that option. And there are many opportunities for domestic mining. Again, not being a professional in the economics of domestic mining practices, but just from my initial research, I understand that there are domestic lithium iron phosphate mines in, here in the United States. So if we can invest more heavily into those local mining practices, I think there's a clear advantage for the economics of these products and for our industry. So what does a typical installation look like? Again, this is a brief overview. There are, perhaps some smaller steps in between here, but generally speaking, this is what's to be expected. So as a homeowner, you're going to gather a number of quotes. You're going to select a contractor that you feel comfortable working with. At that point, you typically would sign a contract with that contractor. You might submit a deposit, and then they'll come out and do a site inspection. Once that site inspection is completed, they'll go through an engineering process with you as step 2. Engineering is seen as confirming the design for solar and battery storage, typically requires an electrical engineer and a structural engineer stamp of approval. Once the engineering phase is passed, the installer should take care of all the interconnection paperwork with you. And of course, I can only speak to my experience working with the companies that I've been affiliated with, although I do know that most local installers are going to handle all of the utility correspondence for you. So that includes what we call the pre-interconnection application, the SMART program application, which is a local incentive, as well as connected solutions, which is a incentive that's specific to battery storage projects. We do see that it takes different amounts of time to work through this utility approval process. Generally speaking, for most projects, we see somewhere from 4 to 6 weeks between submission of these applications and approval. But that timeline can be variable based on the size of the system that's being proposed. So generally speaking, anything less than 15 kilowatts AC, and AC refers to the total battery or storage capacity or inverter capacity that's on site. And your installer, again, will calculate this and be able to know this. But anything less than 15 kW AC would go through what's called a simplified application, which is as straightforward as it gets. Anything that eclipses that threshold, greater than 15 kW AC, will be submitted with what's called an expedited application. And an expedited application does take longer to approve, typically up to about 90 business days for approval for expedited applications. So for larger projects, there is a longer approval timeline, which should be reviewed and discussed with you prior to starting the project so that you have a clear understanding of what's to be expected. One thing I do typically like to ask folks is to be flexible as well with your contractor. There are many factors that are outside of the contractor's control, such as these utility approvals, different timelines, working with inspectors, managing their schedules, managing all the weather variability that we have, which can affect our construction calendars. So I always ask folks for their patience if things don't go exactly according to schedule. And it would be my hope that any installer that you're working with is expediting these timelines to the best of their ability, which I'm sure most folks are. Once you have final utility approval to interconnect the proposed system, your installer will schedule the installation. Now, based on their lead timeline, I couldn't say exactly when that installation will happen. I know within our organization, we like physical installation to come roughly 2 to 3 weeks once we get utility approval. We cannot move forward with physical installation until that utility approval happens. And homeowners are typically CC'd on all of the communication with the utilities. So whenever a contractor gets a notification from the utilities, the homeowner should also receive that same notification. Typical installations usually take somewhere between 1 to 3 days of physical construction on site at your home. That, of course, will include all of the work at the roof if you're having solar installed, all of the work on the battery, and all of the wiring of the electronics. You will get a separate meter associated with the system that typically is installed by the utility company, which is called your net meter, which measures both production and consumption. But again, your installer should be handling all of that correspondence with utilities to make sure that that meter is installed in a timely manner. Once all of the equipment is installed, you'll go through a series of final inspections. That includes a building inspection and an electric inspection. Once you pass those inspections, you then have authorization to turn the system on live. I should say here, there is also a final utility approval that we go through, which is called permission to operate. So once you receive approval of the final inspections, you submit paperwork to the utility to authorize what's called PTO, permission to operate. Once you receive that PTO, then the installer can turn the system live and you should be good to go from there. So let's talk about some popular options on the marketplace. We see that there's a number of companies here that I feel are reliable in the space and are leading this space currently. We'll start with Enphase. Enphase is the preferred company that we choose to work with. Enphase makes microinverters, and they entered the marketplace about 15 years ago. They are seen as the industry leader in microinverter technology, and back in 2015, they launched their battery. And so the battery pairs seamlessly with their microinverter solution. This is what we've seen be the most reliable technology that's on the marketplace so far. But I will say with a big asterisk here that this is evolving. And we understand that there are a number of companies that are offering fantastic solutions in the marketplace. Tesla is another company that I'm sure most folks here are familiar with. They do have their product, which is called their Powerwall, which we really see as the most media-friendly product on the marketplace. It is one of the cheapest options on the marketplace as well. It is a lithium-ion battery. And I should have told you for Enphase, that's lithium iron phosphate. So Tesla is a lithium ion. It is one of the cheapest options, but their company is certainly making waves in the space, and the competition is healthy. I've heard that folks have had issues commissioning their systems with delays, both on the Tesla side and on the utility or local regulatory side. But I couldn't directly speak to that. I have not designed or installed any Tesla Powerwall systems. I've installed a number of systems, including Enphase, SolarEdge systems, and Sonnen systems, as you see here. Sonnen, we'll go with them next, is the first company to really come into the space. They are seen as one of the best battery options as well. They're lithium iron phosphate. And that certainly is something that we would recommend folks evaluating as well. I have designed a handful of Sonnen batteries in the past as well, but also one of the most expensive options that's out there. SolarEdge is another company that's very popular. They design and manufacture central inverters. So it's a little bit of a different type of solar technology. And we could certainly cover that perhaps in a different webinar. But instead of having a microinverter like Enphase produces, you would have a central inverter here that SolarEdge makes. So all of the energy comes off the roof into one inverter, then goes from DC to AC. So SolarEdge also has a battery solution that was introduced several years back on the marketplace. The last company here you see is Generac. And Generac, of course, is a major generator manufacturer, perhaps one of the most well-known. And they do have a solar battery that's come out on the marketplace. They are lithium ion, so that's that NMC chemistry. And they do come with their own integrated inverters, which I have heard mixed reviews on. I've heard that it is somewhat simple, but there are some pitfalls in the technology there that we'd love to see them overcome, as years go on. So let's talk a bit more about the humanitarian issues associated with cobalt. So again, referencing some of these recent media releases, we see terrible working conditions from the majority of cobalt mines, including forced labor, child labor, folks working for dollars a day to feed themselves, and I think an environment and in a world away from us that we just really can't even consider until we see it with our own eyes. And there certainly is media and video out there now that's being presented, and for sake of time and just not wanting to present that, you can certainly look those videos up and see the conditions that these folks are working in. It's drastically hot. They're breathing in toxic dust all day from this cobalt mining. They're clear cutting forests, rainforests, to mine, for this mineral. They're contaminating local water sources. And again, there are companies who are claiming that they are cleaning up their supply chain, but I believe the number is close to about 80%, 70%, excuse me, of the cobalt in the world comes from the DRC, from these types of mines. And China processes about 80% of the world's cobalt. And again, many of the mining companies that are mining in the DRC are Chinese-owned organizations. So again, I think it's important to have that transparency, to know where your purchase dollars are going towards, and to avoid that whenever possible. We're not trying to pull on people's heartstrings. We're just trying to present information as it should be, to allow consumers to make informed purchase decisions. And of course, we want to avoid greenwashing, right? We're in the industry of promoting sustainable development. We're in solar and battery storage so that we can reduce our reliance on fossil fuels, so that we can reduce our carbon footprints and make a positive impact on our communities locally and globally. And we certainly don't want the back-end manufacturing process of these components to be a volatile process on the earth and on the communities, where these are being sourced from. So I want to go over some technical considerations when it comes to batteries. The first, and probably the most important, is the size of the battery. Now, the size is going to differ based on the needs of the home. So one of the first levels of analysis that we go through with folks is to understand which loads in their home they'd like to have backed up. And we typically see one of two options. We see either what we call a critical loads backup, where an additional sub panel would be installed, and the critical loads which you've selected will be wired to that sub panel. So in the case of a power outage, the battery will automatically engage the loads on that sub panel and then partially power your home. The other option would be to do a whole home backup. And whole home is just that. It's going to back up your whole home. That, of course, requires a much larger battery. And one of the big considerations that we're facing right now is folks that have all electric homes, whether that's heat pumps, mini splits, geothermal heating. Those loads all consume a very significant amount of electricity. And in order to back those loads up, you need a much larger battery to do so. Just as a rough example, I would say anything less than 20 kilowatt hour battery will probably cover the majority of those critical loads or those backup loads for a partial home backup. Somewhere between 20 to 40 kilowatt hour battery storage would be needed to back up a whole home. And again, those numbers are variable based on all of the factors that you'd consider: the size of the home, the amount of loads in the home, the amount of anticipated runtime that you'd like to have that battery in place if the grid goes down. So what can be tough here as we go through this analysis with folks is to understand what size battery is needed and for how long. And we tell folks that there's no guarantee on the length of battery runtime, because that really is dependent on the user. It's dependent on how many loads you're running when the grid is down, for what period of time. And it does take, I think, a much greater degree of awareness from the homeowner to manage those electric loads so that they can extend the life of the battery as much as possible. Now, it is fairly straightforward because the battery manufacturers will give you an app or monitoring platforms that you can manage your energy preferences when you're in these grid outage situations. So you do have full transparency into the energy needs of your home when you're in a grid outage situation. But I always recommend that folks work with their local installer to get a clear analysis of the energy needs of their home in order to design the right battery storage option. Backup time, briefly touched on this here, but again, it's very difficult to say how long a battery will last for folks without including a lot of assumptions into that model. We could assume then if there's no sun available and there's only 20 kilowatt hours of battery storage based on the amount of loads that we've wired to that battery, we could give you a general understanding of how long that battery will last. However, when you pair a battery with the solar system and the sun comes out during the day, but the grid is still down, then your battery will continuously be recharged by your solar system. So the system can feed the home as well as feed the battery in a grid outage situation. Now, I want to pause here and say that this is based on the batteries that I have the most familiarity with installing and designing. I know that there are some batteries out there that don't charge off grid, that do have some trouble with that type of functionality. So again, I would work with your installer to understand what the exact benefits are and technical specifications are of the battery when you're in an off-grid situation, and how that will affect you if and when that time comes for you. We want to talk about reliability, and I really think that comes down to working with a manufacturer who has proven technology, low failure rates, what type of features you want in a battery, as we mentioned just before, what type of integration you want, and that really comes down to the type of inverters you might have on site already if this battery is a retrofit, or if it's an all brand new system. Again, looking at what's the best battery and solar pairing for the needs of your home. There's no perfect answer, and I don't want to say that there's no clear one winner on the marketplace. But again, it really just depends on the specific needs of your project. Another consideration here is the location. So where will the battery be installed? Typically, that's going to be in a garage, a utility room, a basement. One of those three locations are generally speaking the three outlines that we offer to folks. And of course, they select where they would like to have it located. Batteries are, generally speaking, allowed to be installed outside, and they can withstand the elements. However, it's not something that we recommend, and that's because of the weather variability that we experience here in Massachusetts. So there will be drastically cold times in the winter. And these batteries have an ambient operating range, typically somewhere between 20 and 80 degrees Fahrenheit. So once we get outside of those optimal operating ranges, the battery will lose some of its efficiency. And if you go below 0 Fahrenheit for most batteries, they just won't work at all. And you could potentially damage your battery by trying to operate it in that environment. So you have to pay close attention to what the warranties for these batteries look like, but it's always the recommendation of myself and our organization that batteries be installed inside, which leads me to my next point. Batteries installed inside do have to abide by a fire code. So there are certain setback requirements, there are certain material requirements that are needed inside of the home or inside of the room that the battery is installed. The room does have to have fire-rated sheetrock in most cases. It does have to have a hardwired smoke detector. It can't be within certain feet distance of different living areas. So there are certain considerations that need to be taken into account with these batteries when they're installed inside. When you get greater than 20 kilowatt hour battery, then some pretty significant changes need to happen to the room where that battery is being installed, which can add cost to the project. So, again, it's this fire-rated sheetrock for the walls and these other requirements that are needed. And that's available on the state website. And I can certainly provide that resource for this fire memorandum, which is what we use to understand what's needed for the batteries. But this is an area between the fire code and the electric code, as you can see as my last talking point, that I think there is some confusion from local inspectors, from state officials, from contractors as to the exact specifications of what is needed for these batteries. So in a perfect world, and what I see as a clear solution is to have a single place, whether that's a website, a state website, or some other resource that lists all of the requirements for solar and battery storage that contractors can go to, that homeowners can have access to, as well as local officials, both fire inspectors, electrical building inspectors, so that all of the code is listed out there, plain as day, so that people can understand exactly what's to be expected. because again, there is some, I think, some ambiguity as to how these codes are being translated on a town by town level. So that can cause some issues down the line with these installations. There are several incentives that help folks reduce the capital cost of installing a battery. The first one we'll discuss here is the Connected Solutions Program. So this is available for both Eversource and National Grid customers, which allows the utility company to access the battery, discharge the energy of the battery to the grid during peak demand times, and every time you participate in one of these events, you will receive a cash payment. Typically, those payments are made twice a year for folks, and the payments are based on not only the size of the battery, but more specifically, the amount of energy that's present in the battery when they call a Connected Solutions event. So again, working with your installer, you can understand the different run cycles of the battery and the different operational modes so that you can then have a clear understanding of what's to be expected for Connected Solutions revenue. It is the responsibility of the homeowner to make sure that when they get a notification for a Connected Solutions event, that they have the full charge capacity of the battery. And if they don't, then you have the awareness that you might not make as much money that was initially projected, because I think most solar installers assume that homeowners will be participating in every projected Connected Solutions event. Between National Grid and Eversource, I believe the numbers are slightly different, but roughly speaking, they do assume about 50 of these events annually as of right now. So I think that's what most installers are using as they're helping to calculate the individual income for your battery project. The other incentive is a federal tax credit, which is the same as the solar federal tax credit, as many folks are probably familiar with, which is 30% of the total cost of the system. So assuming that you have a tax liability and you can utilize this tax credit, then the year following the installation, you can claim 30% of the total cost of the battery and solar combined. Now, there is one caveat here, that the battery must be charged via the solar system. So although this is rare, it is possible for some batteries to be charged via the grid. And they can be installed as a standalone battery without a solar system. That is something, you know, again, we don't see too often, but that is a possibility. But I just like to mention that that is the one item of fine print, that the battery must be charged from the solar system to create a fully sustainable solution for your home in order to qualify for that tax credit. The final program here is what's called the SMART program. This again is a solar incentive, but there is a bonus for battery storage. So when you install a battery within the SMART program, you get an adder to the base rate of the SMART program. The way that adder is calculated is based on the size of the solar system and the size of the battery. So again, working with your installer, they should be able to give you reliable figures to work with so that you understand the investment analysis and what's to be expected from this SMART program incentive. SMART program incentive values are pulled directly from the state, specifically the Department of Energy Resources, the DOER. They have developed this program and they provide resources on the SMART program's website so that homeowners can also go in and calculate their own incentive and verify the information that installers are telling them. I will mention here that the SMART program is coming towards the end of its life cycle. What we see is that the SMART program has different incentive values for different load zones. So load zones are different geographic regions in Massachusetts. Really the only place where the SMART program is really active right now is in Eversource East. So again, Eversource East is a load zone, and you would have to look at a load zone map to see if your town is within that Eastern territory. And if it is, then the SMART program is still available there to you. For all other load zones, the SMART program is dwindling, or it's at a $0 value. There may still be a battery adder available to you. So even if you have a $0 base rate for the SMART program, you may still be eligible for that battery storage adder. So again, it's something to discuss with your installer as you look to evaluate those options. couple of last considerations here as we look at things that come up very frequently for our customers who are evaluating these options. For heat pumps and mini splits, geothermal, we touched on this briefly, but again, it does take a much larger battery to be able to back up those loads. And I think it's probably not the most cost-effective solution for most folks. So just be aware, you know, if you're thinking that you've got an all-electric house, you want solar and battery storage, and you want to make sure your heat specifically is the main concern that I always bring up for folks is backed up, then you will need a much larger battery. One thing that I do know of is that there is a financing option for batteries. It's through Mass Save, which is their mass heat loan. Again, this is a state program that can offer $25,000 as a maximum principal for the cost of the battery, and that is for 0% interest and 0 down. Essentially, the state subsidizes the cost of the interest rate for the homeowner, and that, of course, is a great option for folks, you know, who would qualify there. So again, you would work with your installer to see if you would qualify for that program, and you'd also go through an application process with Mass Save. Can batteries and solar charge an EV? They can on-grid, but off-grid, it's not something that we see as feasible. And it's a simple numbers calculation that we look at. So again, say these home storage batteries on average are somewhere around 20 kilowatt hours for most folks. The size of a battery in an EV is typically somewhere between 80 and 100 plus kilowatt hours. So it would take all of the energy of your solar system and your battery for multiple days on end just to get one full charge of an electric vehicle. So unfortunately, the technology just isn't there yet. But as we look towards the future, we do see potentially the opportunity for your car vehicles, your electric vehicles, to act as battery storage for your home. Now, from my understanding, the only available option right now, I believe, is the new all-electric F-150, and they have some infrastructure that you can install that will allow for this functionality of this bi-directional charging. But as far as I know, that's the only vehicle that's on the market, and it is a brand new technology. So we typically don't recommend that folks be beta testers for this technology or invest into something that's not really yet proven. But I think it's a pretty cool technology, and I do think that it will serve a really wonderful function in the marketplace once that does become more feasible. Keep in mind, one of the big things that I think is an obvious sort of downfall, if you take your truck out, for a drive and the grid goes down, then you don't have any battery storage. So the only true reliable way to have, on-demand battery storage for your home is by installing a home storage battery. That's everything I have for you folks. And I appreciate your time and attention. And I hope this information was valuable to you. You can always get in touch with all the folks here at Metro West or Energize Wayland that can give you some objective information. I myself as well can always be a resource for anyone who has questions about the solar and storage marketplace. Thank you.
Thank you, Matt. That was a terrific overview of a whole lot of technical information and very well done. I also note that East Coast Solar has its own website that people can check out if they're interested in your company and the services that they wish to reach out to you, contact you.
Thanks so much.
So we've done a broad overview of the battery market, the different types of batteries. We're going to get into that. There's already a lot of questions about the different types of batteries and the environmental and the humanitarian footprint associated with different types of batteries. We're going to get into that. But before we do that, we thought it would be great to have at least one local case study of someone like us, crazy enough to consider installing a battery in their residence and trying to do the right thing and what's involved, the specifics of what's involved with a project like that. So we invited Jim Metcalf to join us tonight, and I want to just hand it over to Jim for a few minutes to share his experience, his journey, his case study in installing one of these whole house battery systems here in Wayland. Welcome, Jim.
Thank you. Um, Stephanie, you will bring up my slides. We began thinking about solar power in 2017 after we got a new roof. We had two companies come and suggest plans. In each case, we wanted some changes. One of the companies wanted us to cut down a big maple tree that we did not want to lose. Anyway, they promised to come back with modified plans, but they never did, and we got diverted and didn't pursue the matter, but we kept thinking about it. In 2020, we realized that the federal tax credit was going to be reduced from 26% to 22% in 2021, and we thought we'd better get going. And so we contracted with Sunrun through Costco because we had had good luck with Costco connections and some other purchases. The next slide shows our timeline. I'll return to this at the end, but I wanted to talk through it first. We signed our contract rather late in the year, but we still hoped that we could get in on the 26% tax credit. In less than 2 weeks, a Sunrun technician came and conducted a survey of the house and surrounding trees, and we felt like we were moving ahead. Then it took about 2.5 months to develop the final plan, and we resigned ourselves to the reduced tax credit for 2021. By late January, the panels were on the roof and the batteries were in the basement. And at that point, we were very favorably impressed with Sunrun's performance. We then had to wait nearly 4 months for Eversource to approve our initial application and the town electrical inspector to inspect the system. And at that point, we thought we would be ready to operate. But the state had just put out proposed new guidelines for fire protection. And so we had to wait for those to get settled as to what was required and what was required for home versus for residential, for commercial installations. It became evident that we couldn't have the batteries in their original location. But the plan for their new location and the required enclosure had to be approved by an engineer and the building inspector and the fire inspector before Sunrun could proceed. When they got to doing that work, the process of moving the batteries and constructing the fireproof enclosure involved only about 3 or 4 days work, and no one ever explained why that work was strung out over 3 months. One of the issues was whether the room needed ventilation or not. It turned out that it did not, and whether the door should be rated for 90 minutes or 150 minutes. Fortunately, we were not charged for that additional work, and we finally went operational in February 2022. And in fact, we didn't have to pay for it until 2022. But I'll get into that a little later. The next slide illustrates the survey. The technician brought a drone that flew a programmed pattern over the house to measure the area and slopes of the roof segments. The preliminary design shown here called for 20 panels in 3 clusters, including 10 on a shed dormer, which was determined later not to be strong enough to support the weight of the panels plus a potential snow load. The final design, next slide, please, is 23 panels in 4 clusters, 3 of which are shown here. It seems counterintuitive to have panels on the north side of the garage, which is the opposite side from what's shown here, but they do get sun, especially in the spring and summer, and even already they're getting a few hours of good sunlight near the middle of the day. Now I want to get into the details of the batteries. If I could have the next slide. This is the plan of our basement with some annotations. We had some additions to the house in 1998, and the one at the bottom of the diagram is for a living room that has a dropped floor, which results in a ceiling height of just barely 6 feet in that area of the basement. But given the location of the service entry at numbered 4 and the circuit breaker panel at 3, it seemed reasonable to put the batteries along that south wall at position 5. But then when we learned that they would have to be enclosed with other requirements, it was evident that they would have to be moved. And it turned out that we had an excellent potential location at the number 6, which is kind of a little niche below the front entry to the house, where 3 sides are concrete. The one side being the original foundation wall, and then the way the addition was constructed, 2 sides are the 1998 addition. And then the next slide shows that little niche for the batteries before construction, and then the finished room with a 90-minute fire door. And then we have 2 power walls with a total capacity of 20 kilowatt hours. And they are supposed to power us for a day or 2, depending, as Matt noted, on usage. And of course, the solar panels will recharge them whenever the panels generate excess power. The next slide shows something of our usage. Eversource installed the net meter in late March, and so our production was first recorded on our April Eversource statement. Our billing cycle typically closes each month between the 25th and the 27th of the month, so it's almost exactly corresponds to the calendar month. The design goal of the system was that our annual production equal our annual usage, expecting an excess production in the summer and a deficit in the winter. And if you compare our production to date, the yellow line, with our usage in 20 and 21, the red and orange lines, you can see that it's likely that that goal will be met. Our usage in 2022 was unusual because we had our daughter, son-in-law, and 2 young granddaughters living with us from mid-April to New Year's Day, which means more hot water, more dishwashing, and more laundry, and a lot more electricity. But our production did exceed our usage in April, May, and June, and so we received a credit on our bill in those months. The next slide is the cost summary. This lists the components that we bought. These are what were offered by Sunrun. I don't think they gave us any option on the batteries. Tesla was what they offered. And so you see the total $50,250, that was what was quoted to us when we signed the contract. And as I noted, they did not, even though the contract had a clause for possible additional work, they did not charge anything for the extra work of moving and enclosing the batteries. And I've noted the 30% federal income tax credit, which we have claimed. The Massachusetts tax credit is limited to $1,000. So we're claiming that. And then we also received a Costco cash card as part of the benefit. And so $31,725 was our effective net initial cost. Then we have the accruing additional benefits, the net meter credit. That, as I mentioned, we only got that in 3 months of last year, but we'll probably get some more in the coming months. And then the Mass Smart program, we were unaware of the added benefit of Mass Smart for batteries. That's something we'll have to inquire about. And also we were unaware of the connected solutions benefit. Nobody mentioned that, but so we'll look into that too. So it appears that our, well, the net meter credit may amount to something like $250 to $300 per year. And the Mass Smart benefit should be about $1,000 per year. I calculated cost avoidance as the amount that we would have paid Eversource for the power that we generated and used on site, which appears to be roughly $2,500 a year. And of course will increase as rates rise. And the combination of all these benefits should enable us to break even in about 9 years. So in closing, I want to revisit the timeline just to make a few points. If I have the next slide. We were apparently pioneers in Wayland with our battery installation, at least under these new state guidelines. But now that the state guidelines are in place, I would expect that anyone acquiring a similar system would have a timeline roughly 10 months shorter than ours. Although we were frustrated by the long delays and sometimes were unable to get timely answers to our questions, we were generally satisfied by our experience with Sunrun. And of course, we are very pleased to have reduced our dependence on fossil fuels. And with that, I will close and await questions and further discussions.
Great presentation. Thank you, Jim. That did a very nice job of presenting a solid local example of the issues that come up, the considerations, the questions, and the like. I do want to make sure we leave a little time to speak to some of the permitting challenges that you faced and that Matt alluded to. But before then, I do want to just address some of the questions. I see that Matt's gone in and answered a lot of them, but I did, there was a couple questions that came in over the chat and also using the Q&A function. One, Matt, people were slightly confused by the terminology for NMC, nickel manganese cobalt batteries versus lithium iron phosphate batteries. I think people wondered if there was any lithium involved in the NMC batteries, and my understanding is there is, that the lithium is almost dropped off for that acronym, but you know, if you're there is lithium involved in all of these battery systems, and the other key point is, and this is something that we were just talking about, exchanging information offline on about, is there really isn't a lithium battery system that doesn't involve cobalt as well, chemically speaking, at least in terms of how they're deployed with these sort of systems. Just to get the electric or the battery effect, an anode and cathode, you need lithium and cobalt or something like cobalt to make that happen, chemically speaking. So all these battery types have some cobalt in them, And that's the big concern here from a human rights perspective, among other things.
It's so, and I won't, again, I try to have as much of an understanding of all of this technology as possible without being, a chemical engineer. But it was my understanding that lithium ion batteries are completely cobalt free. And I don't know if there's sort of micro amounts in there, and that'll be something that I, certainly can go back and verify. But all the resources that I look at state that LFP batteries do not contain cobalt.
Okay, yes, so yeah, the lithium iron phosphate batteries don't have cobalt. They're using they're probably using the phosphate and the iron as the a replacement for cobalt. But most of the others, including the ones in our phones and our
right. Right, and that if we just go back to that term energy density that I use, typically you're seeing that the lithium ion batteries, again, NMC, yes, there is lithium there as well. They all contain cobalt because they are lighter in weight, and they do supply faster charging capabilities and higher energy on demand. So that's why they're typically used for phones, laptops, certain other electronics. But I do see the marketplace evolving to shift away from that. From my understanding, there is a strong area of research and development into lithium iron phosphate that allows for very similar type of energy discharge as a traditional NMC battery. Again, this is sort of cutting edge, and this again is how the landscape is evolving. It is still quite a new technology. I think battery technology and energy storage is one of the critical developments of our time. It really is, as we look to transition to more renewable energy sources. So it's an exciting time, but it certainly can be confusing for myself included. I learn something new every day.
Sure, that's helpful though. And I think the different types of batteries is a function of how portable they are, as you alluded to, and if portability is not as much of a consideration, then certainly the lithium ion phosphate batteries make perfect sense to be deployed, like in a whole house battery or for utility scale energy storage. All right, so just a couple other, let's see. Someone asked, and I think you answered this, can a battery system be purchased separately and added to an existing lease or system? And I think you did say it can, depending. It depends, right?
Depending, right. So the companies that I've been a part of have never offered leases, as we see it that it's not typically the best situation for the homeowner to be in from a financial standpoint. Again, we always recommend that folks own their systems, and if you do finance it with a loan, that's still full ownership by the homeowner. There can be a lot of different issues with leases. I don't want to get too much into that because all this information is certainly available online for folks. But with a leased system, then the company who installed that lease would be typically the only one authorized to service it or to add or change any equipment on it. So you would want to always recommend, refer back to that original installer to get that question answered.
Sure. And if you have a PPA or power purchase agreement, or you're leasing your panels, you're probably not, it probably doesn't make a lot of sense to then follow up and have your battery installed.
Yeah, I would see the battery as a little bit more of a luxury for folks. Yeah.
So here's an interesting utility wrinkle. Someone wrote, we were told by Eversource that to install a battery hooked up to our solar panels, we would have to pay $11,000 for a transformer. How common is this? That's a very interesting question. I'd actually like to know more of the details of that one. But have you heard about instances like that? The utility pushing back and saying, look, we have to upgrade our substation or your specific grid area in order for you to do that? So no?
Yes, I have heard of this. And in my tenure, it's happened, I believe. I can recall one specifically. I want to say that there might have been a couple others within our our organizations, but it is rare. However, I think that, you know, and this is sort of alluding back to somewhat of a disjointed nature between these releases and these memorandums, and now coming into actually implementing them with the utility, right? We just raised the net metering cap from 10 to 25 kW. Utility's still not fully on board with that. We're setting different fire requirements for these batteries. We're you know, adding more capacity, more solar capacity to the grid. In order to do so, they do have to modernize. They do have to go through some grid upgrades. And of course, they have their due process and what they prioritize in upgrading those transformers. I obviously, you know, I'm not a utility employee, but I gotta imagine that they're probably not prioritizing transformers for solar projects, right? They're doing it whatever is their first priority. So folks either have the opportunity or the option to pay for that grid transformer, which, as you know, the attendant mentioned, they quoted them $11,000 to upgrade the nearest transformer, or wait until the you know, the utility does that themselves.
Yeah, this is an instance where you know, some far-reaching public policy that obligates utilities to build the electronet, you know, to design a system where power can both be, you know, distributed and shared. And right now, quite often at the utility level, that's, you know, we're not set up for that entirely, especially if you're getting over 25 kilowatts and when you're getting large power sources.
Right.
Jim Metcalf, question for you, because gentlemen, I'm impressed, you know, with just the two of you and an introduction. We are already over 8 o'clock, and I want to make sure we respect people's time. But Jim Metcalf, if, you know, looking at your timeline and the different steps involved, and the process, you know, the necessity to wait for permitting and for local inspections and whatnot, and to actually have to modify your project based on their inputs. If you could do this project again, what would you do differently? And what would you recommend to someone who's considering installing, you know, on-site battery system in their home?
Well, I guess we were content with Sunrun, basically. And after they installed the equipment, they told us that Eversource would take their time about their initial approval. And so that 4 months from January to May, we were just waiting on Eversource. And apparently that was out of Sunrun's control. And at that point, you know, the electrical inspector is here. The only question was whether Eversource would accept the town inspector's okay or send their own inspector. And well, it turned out, of course, that the state had just come out with these new guidelines, and you know, wait a minute, you know, we got to do this and we got to do that, and, you know, and so all of a sudden it was a brand new picture, and by the time we got everything squared away and had the final inspection, you know, it was 10 months later, more or less. So I guess that maybe somebody doing this now, you could go into it a little more informed about the requirements for batteries. And I'm not sure what we would have done if we didn't have that little concrete closet-sized space in the basement. Well, we would have had to put the batteries, I think, in the main basement. And that would have required more construction, because it would have required, you know, identifying some corner and walling that off with two sides instead of just one. But and anyway, so knowing what's required now for the battery installation should make anyone else's project go a little smoother.
It sounds like it might make sense to check in with a local building and authorities and Yeah, and fire inspection
Uh,
folks. No, I don't. Matt, do you guys do that or no? Depends. Probably depends on the town. Go
Sorry,
ahead.
what was your question?
Yeah.
It sounds like it might make sense to check in with the local authorities who
No,
are,
there was a point I wanted to make.
you know, as you begin a project. No, or does it depend?
I think I could speak to that a little bit, because while we were in the midst of waiting to sort out these state fire protection guidelines, one of the things we learned from the Sunrun people was that different town electrical inspectors were interpreting these in different ways, and imposing differing requirements. And in some towns, and I don't remember which, the electrical inspectors were not allowing installation of batteries in residential spaces. And so there's that. I have no idea what some of the surrounding towns are requiring now. And it may be that now that the guidelines have kind of stabilized, it may be easier to do in some of the towns that were hesitant at the outset.
Yeah, I think with the with some state-based regulations and best practices, it probably will help streamline things. Well, I guess that, it's worth checking in depending on which town you're in, and seeing what the local requirements are. Matt, do you want to offer anything here?
Sure. Yeah. And this is an area, as I'm sure you can understand, is frustrating on the contractor side, because again, speaking to, if there was a resource where there was a centralized place where we could read all of the objective information, all of the code, all the requirements for solar and battery storage, so that everyone's on the same page, instead of having this top-down approach and then sort of a different translation, town by town. Every town we go to might require different requirements of setbacks and code enforcement. So it really comes down to the inspectors and each individual town, and even still, sometimes they'll deviate from the letter of the law. So that's why it can be frustrating, because at first we might design a system thinking that we're abiding by the regulatory framework, but then we go to meet the inspector and something else is presented. So this happens fairly frequently. I don't want to say that it happens all the time, but the other issue that we see is that you have the state fire marshal, state electric inspectors releasing these memorandums, and they would make installing solar and batteries very, very, very difficult. And this is something that we see. We kind of hear this word come through the wire of different inspectors starting to enforce things that don't really make sense, but they're getting the information from these releases. And so then they decide to be a little bit more lenient based on the specific design. So that's why it is very frustrating. It can be frustrating for everyone involved, most importantly, the homeowner and the end user. And so there's no clear answer there, unfortunately. As this continues to evolve.
And evolve it will, as we more and more people consider this as a viable option for their home or for their business. Matt, I'm going to throw one more question to you, and this will conclude on this for this evening. Someone asked, if we already buy 100% of our electricity from municipal aggregation, and so it's renewable power, why might we want to install a solar battery system on our home?
Yeah, and I did answer the question there, which is documented. But from my perspective, I want to obviously recommend that anyone that can choose a supplier that is as renewable as possible. So again, I commend that person for doing so. If we look at it from an investment standpoint, you still pay an electric bill, right? So if we want to eliminate that cost of the electric bill by producing our own energy at home, then solar is really the only way to do that, is with that on-site generation. Now, there will still be situations where you have to pull energy from the grid if you don't have a battery, mostly, right? And if we're at night, the grid is down, or sorry, not if the grid is down, but if it's snow is covering the panels, or if it's a cloudy day and you need more energy, then you'll still continue to pull that from the grid, even with solar. Then you still can choose to have a sustainable supplier in that case. But purely from an investment standpoint, solar is the biggest way to offset that cost of an electric bill, as well as the other incentives we talked about, the federal and state tax credits and some of these local cash incentives. So you really put the money back in your own pocket when you invest in your own solar system. And that is typically seen as also the most sustainable option, because you're collecting the energy on site, you're using it on site. There's no transmission losses. There's no other inefficiencies there. So it's a completely decentralized approach to energy generation and consumption.
Great. Thank you very much, both of you, for participating in tonight's program. There will be a lightly edited version of this program on the Metro West Climate Solutions website. Stay tuned for upcoming programs, including a program that we're going to I think most likely be hosting on Tuesday, May 2nd, featuring the Reverend Mariana White Hammond, who currently serves as the Chief of Environment, Energy, and Open Space for the City of Boston. That will be, again, Tuesday, May 2nd. Thank you, Matt Honkonen, and thank you, Jim Metcalf, and thank you all for joining us this evening. Have a good night.